All right, good morning, Algebra 2 folks. Here we go. This is 1-6, the second part, which focuses strictly on solving the systems by substitution. The previous video that you watched or received focused on the method called elimination. And please recall, so we can compare the two, elimination is really nice when everything in the two equations lines up, and we normally line up by standard form. It doesn't have to be that way, but it normally is that way. So like we had the x's, and then the plus minus sign, and then the y's, and then the equals, and then the number. These do not look that way. Yes, some of them are in that form. For example, this equation is in that standard form, x minus y equal number, but the top equation is not. And you'll notice that in each problem, one of the equations is not in standard form. Number 2, that one's not. Says x equals. This says y equals. That says x equals. That's what substitution is for. If one of your equations, or even both sometimes, say y equals or x equals, substitution is a method that fits nicely. Okay, it's not the only way to do it. It's not, it's open to interpretation. But it makes it, in my opinion, the nicest way to go. So let's watch, and we'll go through this. We just have these 4 examples for this video, and there's nothing else. All the stuff I said on the previous video about answers still stands. These are all equations of lines. Lines can do one of 3 things. They either cross, have an x and a y solution, they don't cross and are parallel and have no solution, or are the same line on top of each other and have infinite solutions. That previous video, all that information still stands. Here we go. The equation that says y equals or x equals is the key substituting equation. So notice that the first equation says y equals 6x minus 11. Here's the deal. Y is equal to what I just circled. We are going to substitute that right there in place of y in the other equation. If y equals this, this goes for y. And now we're going to rewrite the bottom equation with its new substitution in and show you why that's important. So it becomes negative 2x minus 3 in place of that y. Get rid of the y, substitute 6x minus 11, and then finish the rest of the equation. Equals negative 7. So what is the advantage of doing that? Like what goal do we attain here? This equation has all x's in it. We can solve for x. That's the goal. You get an equation with one variable and solve for that variable. So you learned solving in a previous lesson recently. Solve this for x, which right now means take care of the distributive property. So negative 2x. Distribute negative 18x. Distribute plus 33. So you got to think of that as a negative 3 times negative 11. Equals negative 7. We have like terms to combine. Minus 2x minus 18x is minus 20x. Plus 33 equals negative 7. Continue solving. We're going to subtract 33 from both sides. We get negative 20x equals negative 7 minus 33 is negative 40. And you can start to see, okay, this is going to work out fairly nicely. Divide both sides by negative 20. Negative 20 divided by negative 20 is positive 1, so x, and negative 40 divided by negative 20 is positive 2. Now, the nicest part of substitution is the first variable you find, this original equation that says y equals is going to be the easiest for finding y. Because it'll be more just plug it in and calculate as opposed to plug a number in and then do all the solve. We did all the big solving work right here to get this x. So you certainly have the choice to take this x equal to 2 and put that 2 right there and get y, or put that 2 right there and get y. this is faster. I'll do that down here. Kind of split the page here. Y equals 6 in place of x. We'll put 2 minus 11. 6x minus 11. 6, that's x now. So this becomes 12 minus 11, or y equals 1. So that's what I mean. That's more just plug it in and calculate, as opposed to plug it in and then have to do solving. Solving is usually what we say when we have to do things to both sides and all that. That's just evaluate. So there we go, x equals 2, y equals 1. We have the ordered pair 2, 1. Which means these two lines crossed each other and they crossed exactly at the location 2, 1. Okay, going on to the next example, the purpose of this next example looking the way it does, the equation can say x equals. It's rare to see an equation say x equals, but it can say x equals. Either way, the y equals or the x equals is the substituting piece. So this says x equals this. This goes for x. There you go. Substitute it. Negative 7. In place of that x, 2y plus 11. Minus 2y equals negative 13. So there's our equation with only y in it this time. We can solve for y, plug it back in, and get x. So here we go. Solving in this particular instance is distributive again. That is negative 14y. That is minus 77. Minus 2y equals negative 13. The like terms are the y's, and it doesn't matter that they're not next to each other. They're on the same side of the equal sign, so it's minus 14 and minus 2, which is minus 16y minus 77 equals negative 13. We are going to add 77 to both sides. That's out. We get negative 16y equals negative 13 plus 77 will be 64. Divide both sides by negative 16. Negative 16 divided by negative 16 is 1y. And 64 divided by negative 16 is negative 4. So there's that. We have y, we go back and find x. When that equation says x equals, that is, again, the nicest way to find x. So we will state, kind of separate our workspace. X equals 2 times y plus 11. Y is negative 4. So x equals 2 times negative 4 is negative 8 plus 11. X equals 3. Negative 8 plus 11 is 3. So the solution is x equals 3, y equals negative 4, hence the ordered pair 3, negative 4. So once again, these are two equations that when graphed would cross each other, and that's exactly the location they would cross each other and share that point. Moving on, we're back to y equals this, it goes there. That's the telltale sign of, hey, we're doing substitution, that those y equals those x equals, because they're easily substituted into the other equation. Okay, that top equation becomes 3x minus 8. In place of that y, we put 3x minus 4 equals 24. So just like the last, substitution method is very, I don't want to say unfortunately, because some people are like, oh, it's repetitive. Then you should be good at it. You basically substitute, distribute, and solve. So we got our 3x. That distributes to be minus 24x. That distributes to be plus 32 equals 24. Okay? Like terms, 3 minus 24 is negative 21x plus 32 equals 24. We're going to subtract 32 and divide by negative 21. So subtract 32. That's out. That's negative 21x equals, let's see, 24, 34, negative 8. I'm going to pause 1 second here, guys. Okay, folks, the reason I paused a minute there is I felt like this question was not happening right, that I either made a mistake or something. So I had to pause a minute. I wrote an equation down wrong out of my notebook right here. So I paused there, scratch what we started. We're going to repeat. Notice this is the equation that should have been here. I mistakenly wrote one from a different example on the page. This should say y equals 5x minus 3. So the precedent is still the same. Still substituting that in, it's just going to come out differently here. So here we go. Let's go through these steps. That's going to be 3x minus 8. In place of that y, we put 5x minus 3 equals 24. Okay, that's what I was looking for. Distribute next. We got 3x. That distributes to be minus 40x. That distributes to be plus 24. Equals 24. Okay, combine like terms. 3x minus 40x is negative 37x plus 24 equals 24. Stay with me. This is a situation that often bothers students a little bit. We are going to subtract 24 from each side. That's out, and I get negative 37x equals 24 minus 24 is 0. It was 0 right here, but I already had a negative 37x. There's no point to me saying negative 37x plus 0. So that I just cross out because it cancels, but if I have an equal sign, I have to have sides. And therefore I write a 0. And this gets people bothered because they're like, oh, no solution. No, that's an x right there. So you have to divide. Divide by negative 37. Negative 37 divided by negative 37 reduces to just 1, x. Folks, 0 divided by negative 37 is 0. X equals 0 in here. This is not a no solution situation. To be a no solution or something like that, the x and the y have to totally go away. They didn't. The x was sitting right there. So it's x equals 0, which is rather nice to plug in. So if I go to the y equals right here, y equals 5 times the x, which is now 0, minus 3. Well, 5 times 0 is 0, so y equals negative 3. X is 0, y is negative 3. In other words, we have 3 straight examples where the lines are crossing because we have an x and we have a y. If we come up with an x and a y, that means the lines cross, and that's the point of intersection. They intersect at 0, negative 3. Okay, last example for this segment. This one says x equals. So x goes right there. So it's 2. In place of that x is 3y minus 4. Minus 6y equals negative 8. Like the other 3, once you substitute, it's most likely distributive property, like terms, solve. Okay, so as I distribute here, that times that is 6y. That multiplied or distributed is minus 8. Minus 6y equals negative 8. Combining like terms, 6y minus 6y cancels. So, newsflash. The variable just went away. This is either no solution or infinite solutions based on what is remaining in this problem. Well, look what's remaining on the left-hand side. Negative 8. Everything else is gone. Equal sign. Negative 8. That's a true statement. The fact that it's true means infinite solutions. Which means in the scope of if this was a graph, the two lines are the same, they're right on top of each other. They don't look anything like each other at the moment, but if we took the time to graph them, they land right on top of each other and therefore share every single point, an infinite amount of points. Folks, I'm not doing an additional example to show you a no solution. We already did a no solution in the previous example. To be no solution, this statement would have to be false. Like negative 8 equals 4. Well, that's not true. Then it'd be no solution. If it's a true statement, infinite solutions. False statement, no solution. All right? Much shorter video than the previous lesson because a lot of the work was laid out in the first video, and this one kind of wraps up the different method, but has the same outcomes at the end. All right? Take care, you guys.